Assalamualaikum to our lecturer, Dr. Siti Ujila Masuri. So today our group want to present about thermodynamic engineering application. So our group choose water dispenser. So our group member is Wan Isati Sahira binti Wan Ahmad Kamal, matric number 201329, Nur Syafiqah Sigam binti Muhammad Azroy, with metric number 201253, and myself, Siti Raudah binti Muhammad Rahim, with metric number 201148. Okay, for introduction, I will give simple terms about thermodynamics. So thermodynamics is a sign of the relationship between heat, works, temperature, and energy. So example of energy is mechanical, electrical, and chemical energy. So in other words, thermodynamics deal with the transfer of energy from one place to another and from one form to another. Okay, so for example, if we have a hot water, so we put a cold ice cube to make the water less hot. Okay. Next, I will explain about what is water dispenser. So water dispenser is a machine that cools or heats up and dispense water with a refrigeration unit. So most of water dispenser were plumbed directly from the main water supply. So the water is normally pumped into the water tank to be heated and chilled. So when it's directly supply main water, so the water will always available. So this is the example of flow in water dispenser. So I will pass to next presenter that will explain about this flow that relates to thermodynamic law.
Okay, thank you Siti Raudah. Now I will explain about the first law of thermodynamics. Okay, so first law of thermodynamics is energy can neither be created or destroyed, but can be transferred or changed from one form to another. Okay, next. So here we have three water dispenser cycle, which is removal of heat from a body, transfer of heat from one body to another, and change in internal energy equal to difference of heat transfer plus the work done by system. So here we have three different processes in refrigerant cycle, which are radiation, convection, and conduction. So radiation is usually occur through electromagnetic wave, and convection is involved between type of fluid which are liquid and gases. Some of the example are heat exchange at evaporator and condenser. And last is conduction. Usually it happen into object with different temperature or only one object involved. Next. So here is a figure, a drinking fountain cooled by a compression system. Now I will explain about the flow. First, a liquid refrigerant flows from the bottom of the condenser liquid line, and then second, it's enter evaporator and evaporate and absorb heat from surface of evaporator, and third, evaporator and vapor gas will go into the battery in suction line, and then the battery will stop at any liquid from flowing into suction line, and then the steam withdrawn into compressor motor, uh, and fourth, the refrigerant will return in liquid and collected the condenser, and lastly the cycle will be repeated. I think that's all for me. For the first law of thermodynamics, I will pass to my group member. Okay, Syafiqah.
Okay, thank you, Wanurizati Sahira. So today I'm going to present about second law of thermodynamics that apply on water dispenser. Next. Second law of thermodynamics states that heat will never spontaneously move from cold places to warm places. Work is required to pump heat from cold places to warm places. A theoretical limit to the efficiency of heat engine. Next. So here is the condition 1, how it's work. To pump heat from room 1 into room 2 to make room 1 cold, room 2 super hot. The second law of thermodynamics states that work is required. Next. As a result, will become condition 2, which using principle of compression and decompression, gases to pump heat from room 1 into room 2 and make room 1 become cold and room 2 become super hot. Next. Nowadays, most of the water dispenser use vapor compression refrigerant cycle, which is compression. Compression takes place to rise the temperature and refrigerant pressure. The refrigerant leaves the compressor and enter to the condenser. Since this process requires work, an electric motor may be used. Second will go through condensation, a heat exchanger. Heat is transferred from the refrigerant to a flow of water. This water goes to a cooling tower for cooling in the case of water cold. Condensation. As the refrigerant flows through the condenser, it is a constant pressure. Thirdly, went through the throttling and expansion. When the refrigerant enters the throttling valve, it expands and releases pressure. Consequently, the temperature drops at this stage. Because of this change, the refrigerant leaves the throttle valve as a liquid-vapor mixture. Lastly, evaporation. Vapor compression refrigerant cycle, the refrigerant is at a lower temperature than its surrounding. Therefore, it evaporates and absorbs latent heat of vaporization. Heat extraction from the refrigerant happens at low pressure and temperature. Compressor suction effect help maintain the low pressure. Next. Okay, this figure shows that when the compressor we apply work as electric consumption, the evaporator will gain heat and produce low pressure at P1. When it flows through expansion valve, the high pressure will occur, and at the condenser, the heat loss. Okay, that's all from us. Thank you.